How do you bridge the sim-to-real gap for robot AI? Imagine training a robot in a virtual world and then expecting it to perform perfectly in the real world. That's the challenge of bridging the sim-to-real gap. When robots move from simulation to real life, differences in lighting, noise, and physical interactions can cause problems. These differences are what make the sim-to-real gap so tricky. To fix this, developers use advanced simulation tools like NVIDIA Isaac Laboratory and Gazebo. These simulators create detailed physics and environments that mimic real-world conditions closely. This helps robots learn in virtual settings that are more like real life. Another key method is domain adaptation. This involves changing the simulated data to look more realistic. Generative adversarial networks are used here. They transform synthetic images into ones that look real, helping the robot recognize objects better. Object-aware approaches are also important. For example, Retinagan focuses on keeping the shape and structure of objects consistent during the translation process. This makes sure the robot can recognize and interact with objects accurately in the real world. Reinforcement learning is another powerful tool. It allows robots to learn through trial and error in many different simulated environments. This helps them develop skills that are more likely to work in real life. The sim-to-real-to-sim strategy takes this a step further. It involves training in simulation, testing in the real world, and then updating the simulation based on real-world results. This cycle keeps improving the robot's performance over time. These techniques are used in many robotic tasks like grasping objects, assembling parts, or walking. For example, a robotic arm trained in simulation can perform precise assembly tasks in real factories. By combining realistic simulation, domain adaptation, object-aware methods, reinforcement learning, and iterative feedback, we can make robots more reliable outside the lab. This approach helps bridge the gap between virtual training and real-world application, making robots more useful and adaptable in everyday life.